Where are the napkins? I don't know that we stock all the classrooms with napkins. All right. So for today, everybody was supposed to get their scripts folder onto GitHub, right? Rather than using the Unity git ignore, which still puts your assets up there. And as soon as your project gets too big, it'll start screaming that you need large file support, and then the world starts exploding. So if you keep going with some of the Unity stuff, it's totally doable. You can look into storing Unity things on GitHub in full. But I would probably just do something like Dropbox or something like that and share a link to the folder that way for the whole project, and then just share code on GitHub or something that you want to collaborate with people with. Okay. So we want to start talking about our world here. Now, we've already talked about players a little bit, and I know we've kind of removed our players. They started a new project last time. We'll put them back in at some point, but let's start thinking about our map. All right. So if you remember back to last semester, do I have I bring that picture over? No, I didn't. I'm going to steal that slide from our cross map. All right, so we created our dungeon that looked kind of like this last time, where we had 6 rooms and we had a whole bunch of exits between rooms, and we had an exit going in each direction coming out of there. I got nothing on. Oh, that's fun. Super Ninja. That one? Nope. That one? All right. Was that ever up before? And it went away? Or is this the first time you've seen it? Okay. All right. So in any case, we had this as our dungeon we created. Now, so last time we created a whole bunch of Java classes to represent our rooms and our exits, and then rooms held a collection of exits and all this stuff. So we want to understand, well, we want to, let's call it, reimagine how we might build the idea of having rooms like this, because we want to put our guy into a room and then have him be able to traverse our dungeon. All right. Now, we have multiple ways we can think about this. On one hand, we can have our, when we think about how Unity works, we could generate a whole bunch of rooms that are like, squares or something like that, similar to the playing field we did for our rollerball, that type of thing. And then each room kind of has cutouts on, wherever the exits are. And you could, maybe click on that thing and move towards that if we're trying to put things together the way we've thought about it, the tools we've used in class so far. So then as your dungeon got bigger and bigger and bigger and bigger, you would start having one giant scene with a zillion rooms in it. Now, how many of you have ever played a video game, one of these open world games or something like that, where only portions of the map fit in the world at once? And sometimes you have to get to a place where you like zone into another place and it loads kind of the next portion of the world or something like that. We've seen that before. All right. So, in the some of the earlier like MMOs, like EverQuest, for example, It was much less obvious in there. You'd just be running down this line, and you know, all of a sudden all you'd see is like a path in front of you, and all of a sudden you just start zoning into the next place. Um, uh, that was a problem back then, with people would get, they would make some high level monster or something mad, and they would chase them, and they would run it to the zone, and they would yell usually to warn people. But once they zoned out, the bad guy couldn't chase them anymore, but he would go and attack anybody else who was right around there instead of reset back. So people would screw with people by just running high level monsters into them. Um, Good old days. All right. So we have to start thinking about system resources at some point. Probably not going to be that big of a deal for us, given the size of the thing we're likely going to create. But it's something you do want to think about. And this isn't just a Unity thing, it's any kind of software thing. We do have limited resources, and we have to consider, given the constraints that we're working with, that is, you know, processing power, amount of RAM, things like that. You know, that's going to dictate how many things we can kind of have happen at once. How much of a world can we have loaded at once? Um, you know, you've seen it with a lot of your you know, other online games where, you know, when you log in, you like join a server, right? You know, you do US East or US West or something like that. So they have servers kind of placed in, you know, geographic locations relative to where people might be connecting, because the idea is your connection speed might be a little faster or something like that. That's not always the case, but let's say it potentially could be the case. But it also allows them to kind of segregate the number of people playing the game across multiple servers, because sometimes you'll see like a server is full. You can't join that one, but you can go to another one that has less people in it. That's the idea of a game kind of managing its resources, because there isn't an infinite amount of memory, right? You know, and when we're sitting here playing our single player game, yeah, we could probably build a pretty big world, and it wouldn't be the end of the world, you know. But you imagine if you have 1,000 people in a world all at once, all doing their own thing, all having the monsters attacking them and stuff like that, it becomes more of a problem. But then even within that, you have to separate. You have to start thinking, okay, well, what stuff happens up on the server, which versus what stuff can we have happen down on the user's computer? What can we leverage their processor and their graphics card to do that doesn't really belong up in the server? Yet the server still needs to know kind of maybe the location of the 500 different people in that world at that time, right? So it knows kind of what guys are near each other and that kind of stuff. So we do kind of need to think about that a little bit. So one thing we can do is we can build these models and move between the world. Another thing we can do is when we look at our game, we see that everything lives inside of this scene. So if we go back here, we have what I have loaded here. I just have the sample scene loaded right now. And this scene has the uh, uh, has whatever we view on a single screen. Now, could we have our dungeon exist where each of these rooms is a scene? So room 1 is a scene, and when we go to the north, what ends up happening is we see the guy kind of leave the first scene, and then the next scene shows up, you know, replaces the old place you were coming. So you were heading to the north, all of a sudden you're heading in from the south to a brand new room, something like that. So at that point in time, you're only showing one room at a time. Now, maybe that's okay if for the nature of the game we're building. Um, you know, if you're building something that's more of an open world thing where you're going to be traveling all over the place and you can see where things are in the distance, you know, you get a different type of experience. How many of you ever played the original Legend of Zelda? Okay, so I'm kind of thinking along those lines for our dungeon. If you did play that game, what would happen is when you started heading north, what would happen is it would kind of, you would start heading into the room, and then the room would slide in, and you now that's centered, and you're in that room now fighting whatever monsters and things like that. All right, so let's go down that path a little bit just from an experimental perspective. So A, we know how to load a new scene. And B, we want to then start thinking about what we thought about last time. Well, we thought about the last couple of classes is how do I have scenes communicating information between them? Will a singleton still do its job? We've had game objects talk to each other through a singleton, but can I have a singleton exist that passes information from two different scenes? Something for us to look at. All right, so let's go to the documentation here real quick. I think it's just called load scene and you give it the name, but let me just confirm that. Scene manager.load scene and you give it the name, feed name. You can also give it the build index. So you can give a scene by its name or by some like a unique identifier based on when you created it. So let's do it based on the scene itself. So let's we want to do this for a starting point. All right, so let's build a couple of scenes here. So we're going to create oh, actually I can do scenes up here, right? File, new scene. We're going to call this guy, so we'll do a basic scene because that already comes with a camera and the light and that kind of stuff. And where do I name that? Oh, does it just create it as a new scene? Then I have to name it from there. Okay, so this is untitled. So let's call this guy, put it in scenes, and we're going to call him scene 1. Just for the sake of argument right now. All right, then I'm going to have another new scene. Also a basic scene. Call this guy, put him in our scenes folder. Call this guy scene 2. All right, I'm going to go ahead and load up scene 1 here, and we'll make some changes to that. We actually could probably dump our sample scene. That one thing you might want to do, though, I probably did this automatically, but just in case, if we go up to, is it Unity or File for build settings? File, build settings. So it's going to show the scenes in the build, and I think actually the scene that'll launch by default is whatever one you're currently on. So I guess that's actually, it's okay. We don't need to do this. But when you actually build your final project, you would add any open scenes in this so it gets put into the executable rather than now we're using Unity to interpret between these. Just something to keep in mind at some point if you were ever going to build a PlayStation game and wanted to export it and try to launch it, load it on your PlayStation, which you can do with Unity. All right, so let's kind of create something that would allow us to get from one scene to another. So let's get a ground in here maybe. So we'll create a plane. And a plane already has a mesh collider. So we're going to call this guy ground. And then let's go ahead and create a cube. We'll call this guy player. Let's give these guys a little bit of color. I'm going to create a new folder, materials. Go into that folder. I'm going to create a material. And we're going to make this the player material. And players are going to be red-ish. So I'll drag that guy onto our player. And then let's create a ground material for no good reason. We'll probably eventually put like a texture on there, like a dungeon floor or something like that. But for right now, we'll call this guy grass. And we'll pick a grassy green. All right, there's our grassy green. All right, and players, we usually have rigid bodies on these guys so they can have gravity impact them. We're going to need that here in a second, so we'll put a rigid body in here. All right, make sure that gravity is turned on, and it is. So if we play this right now, we should see our player fall out of the sky and just land on the ground. All right, so the colliders are interacting with each other. Okay. Questions about that? Just kind of building out a scene real quick. All right. So now let's go ahead and why don't we make it so that when our player hits the ground, something happens. All right. Maybe we load the other scene, for example. All right. So we're going to need to create a script associated with our player. So here's scripts. Oh, we already got a player script. Get that guy open. So now, where would you put the code based on what you know at this point to make it work such that when our player hits the ground, we're able to launch a new scene. We're able to interject some logic. How would you pull that off with our current setup? I think you've done it both ways. So give me one of them. How do we programmatically deal with collisions? Or nothing? Our tutorial was just a monkey see, monkey do. Didn't retain, didn't seep in. So maybe we do an on, what is it? On collision enter. That might be one of them. Does that remind you a little bit? I think maybe on the tutorial, I thought you had to do it on collision enter. The tutorial, I know for picking up the pickup things, you would have done on trigger enter. What's the difference between using a collision and a trigger? If I make something a trigger, for instance, if I come in here and I make my click on my player and I go down to the rigid body here. I'm sorry, we go to the box collider here and we click this box that says is trigger. What difference will that happen in my game now? Oh, first of all, remember my game's still running. Actually, I already kind of showed you the answer, but maybe you weren't paying attention. Okay, so now my game's not running, so I have to re-click the is trigger thing. So now I've made our box collider on our player a trigger. What will that, what happens when you make it a trigger? Why would you make it a trigger? Go ahead, guess.
Well, that's what you'd use for like points, right? For like
Okay, why? What was the behavior we got when we did the pickups or picking up coins, whatever? Okay, they disappeared when we ran over them. And we did that by writing code to make the thing we collided with disappear, right? But we made those triggers. Why? Because we didn't want gravity. We didn't want the physics of our dudes banging into coins and stuff like that, where the coins go flying off in some direction, which maybe you do want that. But, and then you can also make it disappear because I've shown you in code here, you can handle either case, right? So you can say on collision enter, and we'll do a print on collision. So let me go back here now. And we still have this guy set up as a trigger. So I'll go ahead and hit play. We'll see him fall through the ground. Boom. We'll go to console and you see that that guy did not because he did not collide. We turned the physics, the physicality of the collision off. Whereas if I go back in to my script and I do print on trigger and save that, and now I run this. Oh, where's my, what did you do? We don't have debugging turned off, do we? On trigger enter. Oh, give me a moment. Anybody know what I didn't do? Why might my player script not be running any of the code I've written in my player script? I saved it. Didn't attach it to my player. I got this beautiful mono behavior just chilling out there. That is not actually part of my player. See, I always do these things on purpose so you can learn from this stuff. All right. So now we see that it says on trigger, right? And it didn't say on collision. Yet if I go back in here, I turn it back into a normal collider rather than a trigger-based collider. So now I want physics to handle this. So now the player is going to land, right? They'll land on the ground. Now you see we got on collision. All right. So we can programmatically handle either of these. So we can have the world where we want physics to happen, but we still want to throw some logic in there. Both of those things can go down. Make some sense? All right. So let's get that in the notes since it did not seem to be retained great from the tutorial. Did we use on collision enter in the tutorial, or was it just on trigger? Just use on trigger. On trigger enter versus on collision enter. And keep in mind that there's other versions of these, like there's on trigger exit. So you can choose when you want to, you know, be part of this. So here, I'll even show you that. So we'll go into our code here. I'm going to do it on trigger. So here's a on trigger exit. They also have an on trigger stay. So when it's just chilling, but I'll do an on trigger enter. And then we'll do an on trigger exit. And then we need to go make sure our player is a trigger again. So now he's a trigger. Oh, turn it off. Now he's a trigger. So you saw we had two different opportunities there. So we could write code that happens when we first enter a trigger, and you could write a different set of code that you want to have happen when it exits the trigger. Make sense? So for instance, maybe when it enters the trigger, it turns yellow or something. And when it exits the trigger, we load the other scene, whatever. Yeah, that type of thing. All right, so get it in the notes here. Triggers allow you to programmatically handle non-physics based collisions. So on trigger enter allows you to write code that gets called whenever a trigger is entered, even though the object would not be impacted by the automated engine. Yes. There we go. It's spelled perfectly. I think it's Icelandic. Like a 2-year-old throwing a fit. Can't spell it. Just starts slapping at the keyboard. Like that's good enough. Let autocorrect clean it up later. Okay, so that's what triggers are. Collisions have the physics engine do the, call it banging around, or do we want them do the math for how the colliding game objects should behave. Oop. So on collision enter allows us to add additional logic to what happens when a collision occurs through code. All right, so if trigger's turned on, you're not going to see any things hitting each other, but we can still handle it with code. With collision turned on, you are going to see them hit each other and bounce around or whatever, depending on what physics says they should do. But we can still also handle it with code if we want to do something as well. All right, make some sense? All right, so in this particular case, doesn't really matter. We just want to do something. So I'm going to go ahead and we're going to call scene manager. We have to do a using Unity editor.scene management. None in that one. Unity editor dot. Where does this guy say he lives? Unity engines. It is scene management. There's scene management. I have to bring in. Oh, must be called editor scene manager now. All right, and it wants the either the build index. So one thing you can see here when we type something in over here, it says 1 of 6. So we have one where we can give it the index, one that gives it the scene name, one that gives it the index plus the mode we want to load in. I'm sure there's a bunch of other modes, but we're going to give it the scene name here, and we named our scene 2, right? We named it scene 2, no spaces. Okay. So there's our scene 2 that we're going to try to load. Now let's just test it here real quick. Couldn't be loaded because it is not being, oh, build settings, the thing I told you about earlier that we didn't do. So I need to open up scene 2, go to file, build settings, and make sure I add that there too. That way this build knows about the two scenes I want to bounce between. All right. So now we switch to a new scene and we see that this guy is exhilarating. There's a lot going on here in this scene. All right. So now what we want to do is we want to let's give ourselves a let's just do something in scene 2 because we want to have some objects that can have things shared between them. So I'm going to go ahead and we're going to let's create a sphere. All right. And for no good reason, our sphere is going to have the player color. There we go. And obviously it should be a giant sphere, right? So like that. Ooh, look at that. All right. Big sphere. So now let's go ahead and let's write a script that we want to attach to this this sphere. So I'll create a C# script. And let's just call this sphere script. Good enough for our example here. All right, and we will remember to attach our sphere script to our game object this time. We'll go ahead and open up sphere script. All right, now what we want to do here, just to kind of prove that whatever is happening, we're going to go ahead and we're going to say print inside sphere script for right now, just to prove this guy's up and running. All right, so what do we expect to happen? If we switch back to scene 1 and hit play, we expect to see the guy drop through. We'll see on trigger enter. We'll see the new scene launch, and then we should see inside sphere script because this new scene has now launched, which causes the sphere to be born, which causes his script to start. And inside of that start function, we're saying inside sphere script. So make sure you save this scene, and then I'll switch back to scene 1. Go ahead and drop. Right, now we're on scene 2 with the we should put happy face texture on this guy. And here's our inside sphere script. All right. So now what we want to do is we want to figure out how can we communicate between scenes. So just consider in the last week what we've kind of thought about doing, like how do we have game objects talk to each other? And now how do we have scenes talk to each other? And these are major things because, I mean, if you think about a video game, when you first, an old school game, it's, 1 or 2 player, right? You click one player, brings up another scene. Well, that scene has to remember you hit one player, a single player. Maybe you got to type in your name and you hit start. Well, it probably has your name up there somewhere. These scenes had to pass that information somehow between each other. All right, so we need to have a mechanism for doing that. So let's go ahead and let's create our singleton. Remind me, what's a singleton? One of our 2 design patterns. We had MVC, model view controller, and what does singleton do? What problem does singleton solve? That in 1,000 ago. Okay, so it's a good idea to keep things that are shared, that need to be shared between multiple things in a single place. So we're going to go ahead and create a script here. And we're going to go ahead and we're going to call this guy, we'll just call it my singleton right now. I'm going to open that up. First thing we're going to do is we're going to remove the mono behavior, which means it's no longer got to start an update. And we're going to go ahead and give it a static variable to hold a number or something like that. All right, so we'll say static int secret number. All right, we'll start secret number off at -1 because we want the first scene to have the guy update that and then have the second guy prove that he can see that update. Something along those lines. All right, so this is static, which means that it's owned by the class. So how will I access this variable called secret number? What would be the code I'd write to set that guy to a 5? How do I call static members of a class as opposed to instance members of a class? Good.
Name of the class.
Name of the class. So this will be my singleton.secret number. So we'll go into our player script. And on trigger enter, before we load that scene, we're going to say my singleton.secret. I made it public, didn't I? Actually, I shouldn't have to make it public. Secret number is equal to 5. Oh, I guess I do need to make it public. Protects it by default. All right, so now I can say my singleton.secret number. I made it public, so it's accessible in all the other classes. And here, what I'll do real quick is I'm going to say print secret number equals my singleton.secret number. So the first time through, it should be a -1. Then he's going to change it to a 5. And then we're going to see if we recognize that 5 in the other scene when our sphere script launches. So after we say inside sphere script, we'll print out the current value of secret number. All right, makes some sense. Save that. So what we're expecting to see here is a -1, followed by loading a new scene, followed by in sphere script, followed by a, what did I put it as a 5? So there's my -1 inside sphere script, and then my secret number is equal to 5. All right. So we just proved that we can send information between scenes using a singleton. Pretty powerful. Now, remember when we first introduced singletons, I mentioned that you do want to be a little careful with singletons. With great power comes great responsibility. And if you start putting everything into a singleton because you see that, oh, it just works. If I make everything public and I make everything global and put it inside of a singleton, then I don't have to worry about variable scope anymore. Bad programming practice. Don't do that. But if you do need things shared between multiple game objects, or you do need things shared between multiple scenes, a singleton is a good tool for doing that. Now, there are some other mechanisms built into Unity for game objects to communicate with each other. For example, one of them that we will probably use at some point, for instance, has a way of calling a method, a function that might live in a script, to all game objects in the scene. So let's say every single game object in the scene has a method that causes it to double in size. So, you know, it has a function called double in size, and it just, all it does is it updates the transform to be whatever its current scale is to double that. Fair enough? And let's say we have 10 game objects on the screen, and we want every single game object to call its double size function. Well, one way we can handle it that we've kind of done before is we could put into the update function on each one of those guys that it constantly checks some variable in a singleton that just says, you know, function I should call. Should I call a function? Should I call a function? Should I call a function over and over and over again? If it says yes, then it goes and calls whatever function you had told it to call. So you're going to have if statements all over the place. It's going to happen every single time through update, things like that. So that would be probably not great programming practice. Now, event-driven programming would say, hey, we're going to just say, look, we're interested in knowing when you would like us to call this function. So what we can have is we can have one of our game objects raise the event, where it basically yells out, everybody call your double in size function. And all the game objects that have registered to be interested in that event will then automatically have that function called, and it'll do whatever it's going to do. So the only mechanism for communicating between game objects is not a singleton. But singletons are often good choices for sharing data among things rather than behaviors. Make sense? So don't think this is always the best solution. Okay. So what is our next step then? We want to create two scenes, each having a room. Say maybe a room is a square with 4 walls and openings where there is an exit. But you can use your imagination if you want to have your room just be land and have portals or something like that that are on the end. And so when traveling between rooms means you enter a portal, that's fine too. You can use your imagination. So write the code that has the player move toward an exit in a room. And upon hitting that exit, another scene spawns showing an empty room and the player entering from the exit's counterpart. So if we exited a room to the north, we should enter the next room from the south. Make sense? Okay. So you can use your imagination with this if you want to have some cool stuff. All I want from you is the code for the scripts. So submit the self-assessment and the GitHub link to your scripts folder. Okay. So in my mind, the idea of this would be you have your initial room, your player starts off in the middle. All right. Maybe if you you can decide how you want your player to be controlled. You know, you can either have it off of a keystroke if you want to do that, or you can just say after the scene starts, have him start moving to the north. For this example, that's fine. You don't have to interact with the game at this point. We'll deal with that. But if you want to look into how key press works, it's not hard. You can just make it work for the arrow keys, you know, north, south, east, west, something like that. All right. So he should start moving to that. And as soon as he hits it, the scene should end and he should start coming in from the other side. So if we assume he's going north, we should see him coming in from the south and maybe then stopping at the center of the room. All right. So this is going to have you put together a lot of things we've learned today, learned over the last several classes. So you might have empty game objects, for example, for you know, for triggering something, or maybe making sure they come in from the south. For example, when you leave the room to the north and you enter the new room, maybe you keep track in the singleton where you exited the room so you can figure out where you should enter the room from. And then maybe you have some hidden game objects in those areas so that you can quickly change your player's transform to that location and have him start entering the room. As a possible hint. If you want to do it some other ways, you can as well, but I think that would be a fairly straightforward way of accomplishing it. All right, questions, comments, concerns, bribes. All right, I'll put up the link to my current code here. There's not a whole lot going on, but at least you'll see the singletons talking to each other and the on trigger stuff, whatever. And I'll see everybody on, what day is today? We'll see everybody on Wednesday. Well, that's good. That means we have 2 more classes this week of excitement. What's up?